Deep in the heart of reality, smaller than atoms, smaller than the tiniest fragments of matter we can imagine, lies a realm so bizarre that it makes science fiction look mundane. This is the quantum realm, where particles exist in multiple places simultaneously, where information travels faster than light, and where the very fabric of empty space bubbles with invisible energy. Tonight, we descend into this microscopic universe to uncover what truly exists when we strip away everything we think we know about reality. What you're about to discover will shatter every assumption you've made about how the world works. We'll explore a dimension where cause and effect break down, where particles can tunnel through walls, and where the simple act of observation changes the nature of reality itself. From virtual particles that pop into existence from absolute nothingness to quantum fields that permeate every corner of the universe, this journey will reveal the hidden machinery that drives everything from the fusion reactions in stars to the mysterious dark energy tearing our cosmos apart. But here's what makes this exploration truly extraordinary. The quantum realm isn't just some abstract theoretical playground for physicists. It's the fundamental layer of reality that governs every atom in your body, every photon of light hitting your eyes, and every chemical reaction keeping you alive. Understanding what exists in this microscopic universe doesn't just satisfy scientific curiosity, it reveals the true nature of existence itself. Prepare yourself for a journey that will challenge everything you believe about reality, because once you see what's hiding in the quantum realm, you'll never look at the world the same way again. Let's begin our descent into the impossible. Picture standing at the edge of the smallest possible scale of reality. You've shrunk down past molecules, past atoms, past even the nucleus and electrons. You're now entering a domain where the familiar rules of physics collapse entirely. This is the quantum realm, and it operates according to principles so alien that even Einstein called them spooky. At this scale, measured in units so small that comparing them to everyday objects becomes meaningless, we encounter the first shocking truth. What we call empty space isn't empty at all. It's a seething ocean of activity, crackling with energy and teeming with particles that flash into existence and vanish in timeframes shorter than anything the human mind can comprehend. The quantum realm begins to reveal itself at scales of about 100 nanometers and smaller. To put this in perspective, if you could shrink a marble down to the size of the Earth, the quantum realm would be like examining individual grains of sand on that marble-sized planet. At these dimensions, matter stops behaving like solid objects and starts acting like waves of probability, existing in multiple states simultaneously until something forces it to choose. This isn't just a limitation of our measuring equipment. It's a fundamental property woven into the fabric of reality itself. In the quantum realm, particles don't have definite positions or velocities until they're observed. They exist as ghostly possibilities, spread across multiple locations at once, like cosmic dice that haven't finished rolling. The mathematics describing this realm read like poetry, written in a language beyond human intuition. Equations filled with complex numbers and probability amplitudes reveal that at its core, reality operates on chance rather than certainty. The quantum realm doesn't deal in absolute facts but in probabilities and possibilities, creating a universe where the very act of measurement fundamentally alters what's being measured. But the strangest discovery about the quantum realm isn't what exists there. It's what exists there when nothing should exist at all. Even in the deepest vacuum of space, in regions completely devoid of matter, the quantum realm buzzes with invisible activity that shapes the behavior of everything in our universe. Scientists call this phenomenon quantum fluctuations, and they represent one of the most mind-bending aspects of microscopic reality. According to Heisenberg's uncertainty principle, energy and time are locked in a cosmic dance where knowing one precisely makes the other completely uncertain. This creates a loophole in the laws of physics that allows the universe to borrow energy from the future, creating pairs of particles from absolutely nothing, as long as they disappear quickly enough to avoid detection. These aren't theoretical constructs dreamed up by physicists with too much imagination. Virtual particles, as they're called, have measurable effects on the real world. They alter the behavior of electrons, influence the strength of electromagnetic fields, and create forces that can be detected in laboratory experiments. The Casimir effect demonstrates this perfectly. When two metal plates are placed extremely close together in a vacuum, virtual particles push them together with measurable force, proving that empty space contains real energy. The energy density of these quantum fluctuations staggers the imagination. In a single cubic meter of empty space, the energy contained in virtual particles exceeds the mass energy of the Sun. It's as if every point in space contains a compressed powerhouse of creation and destruction, constantly recycling matter and energy in cycles too brief for us to observe directly. This raises a profound question that keeps cosmologists awake at night. If empty space contains so much energy, why doesn't it tear the universe apart? The answer remains one of the deepest mysteries in physics, involving calculations that produce results off by a factor of 10 to the power of 120. It's the worst prediction in the history of science, yet somehow the universe maintains a delicate balance that allows stars, planets, and life to exist. The quantum vacuum, as physicists call this energetic emptiness, serves as the stage for even stranger phenomena. It's here that we encounter quantum fields, invisible entities that permeate every corner of space and give rise to all the particles and forces we observe. Unlike the solid matter we experience in everyday life, quantum fields represent pure potential, waiting to be excited into the particles that make up atoms, molecules, and everything else. Think of reality not as a collection of solid objects moving through empty space, but as ripples and waves in an ocean of invisible fields. An electron isn't a tiny ball of matter. It's a localized disturbance in the electron field that extends throughout the universe. A photon of light is an excitation in the electromagnetic field. Every particle you've ever heard of represents a different type of wave in its corresponding quantum field. This field-based view of reality explains one of the most puzzling features of the quantum realm. Why are all electrons identical? Why does a proton created in a particle accelerator on Earth behave exactly like one formed in the heart of a distant star billions of years ago? The answer lies in the field nature of reality. All electrons are identical because they represent the same kind of disturbance in the universal electron field. All protons are the same because they're excitations of the same underlying quantum field structure. But quantum fields do more than just create particles. They mediate every force and interaction in the universe through the exchange of virtual particles. When two electrons repel each other, they're actually exchanging virtual photons through the electromagnetic field. The strong nuclear force that holds atomic nuclei together operates through virtual gluons zipping between quarks faster than light can travel the same distance. These virtual force-carrying particles pop into existence, deliver their message, and disappear so quickly that they exist below the threshold of direct observation, yet their cumulative effect creates all the forces that shape matter, energy, and the structure of the universe itself. The quantum realm serves as a cosmic post office, constantly delivering messages between particles through virtual carriers that exist in the shadowy space between reality and possibility. The deeper we probe into the quantum realm, the more we discover that it operates according to principles that violate our everyday understanding of how things work. Quantum tunneling allows particles to pass through barriers that should be impenetrable, like a ball rolling through a solid wall. This isn't magic or science fiction. It's a measurable effect that makes possible the nuclear fusion reactions that power every star in the universe. In stellar cores, atomic nuclei lack the energy needed to overcome their mutual electrical repulsion and fuse together. Classical physics says fusion should be impossible at the temperatures found in most stars, but quantum tunneling provides an escape route, allowing nuclei to effectively teleport through the energy barrier that separates them. Without this quantum effect, stars couldn't shine, planets couldn't form, and life couldn't exist anywhere in the universe. The probabilistic nature of quantum tunneling means that given enough time, any particle has a chance of appearing anywhere in the universe. The probability might be incredibly small, but it's never zero. In principle, every atom in your body could simultaneously tunnel to the other side of the galaxy. The odds are so astronomically low that it would never happen even if you waited longer than the age of the universe. But the quantum realm doesn't deal in impossibilities, only improbabilities. This leads us to one of the most counterintuitive features of the quantum realm, the principle of superposition. At quantum scales, particles don't have to choose between different states. They can exist in all possible states simultaneously until something forces them to make a decision. An electron can spin both clockwise and counterclockwise at the same time. A photon can travel through multiple paths simultaneously. A particle can exist in several locations at once. The famous double-slit experiment demonstrates this mind-bending behavior perfectly. When individual electrons are fired at two parallel slits, each electron somehow passes through both slits simultaneously, creating an interference pattern that proves it took multiple paths. But the moment you try to observe which slit the electron actually went through, the superposition collapses and the electron behaves like a normal particle, choosing only one path. This isn't just electrons being tricky, it's a fundamental property of reality at quantum scales. The act of observation doesn't just reveal information about a quantum system, it fundamentally changes the system, forcing it to abandon its multiple simultaneous states and commit to a single outcome. The quantum realm exists in a state of pure potential until consciousness or measurement equipment interacts with it. Recent experiments have pushed superposition to larger and larger scales. Scientists have created superposition states involving thousands of atoms, demonstrating that the quantum realm isn't limited to individual particles. They've built quantum systems the size of computer pixels that exist in multiple states simultaneously, proving that the boundary between the quantum and classical worlds isn't as clear-cut as once believed. But perhaps the most mysterious aspect of the quantum realm involves what Einstein called spooky action at a distance. When particles become quantum entangled, they form connections that transcend space and time. Measuring one particle instantly affects its entangled partner, regardless of the distance separating them. This effect has been demonstrated across thousands of kilometers, proving that the quantum realm operates according to principles that violate our understanding of locality and causality. Entanglement begins when particles interact in ways that make their properties interdependent. Once entangled, the particles share a quantum state that cannot be described independently. They become part of a single quantum system, even when separated by vast distances. When you measure the spin of one entangled particle and find it spinning clockwise, you instantly know its partner must be spinning counterclockwise, no matter how far apart they are. The implications of quantum entanglement stretch far beyond academic curiosity. This for emerging also suggests that ATD quantum cryptography, quantum computing and phenomenon forms the foundation technologies like that it contains reality might be fundamentally interconnected in the deepest level. As we continue our ways that exploration of the quantum realm, we discover classical physics cannot explain. In the classical world, the quantum vacuum itself serves as anything possible for storing and processing information that DW mechanisms data in the correlations between virtual particles and as a vast information storage system, encoding. Every quantum interaction leaves traces in the underlying quantum field fluctuations, field structure, creating an invisible record of events that persists long after the original particles have disappeared. This quantum information doesn't just sit passively in storage. It actively influences future interactions, creating feedback loops that shape the evolution of matter and energy throughout the universe. The quantum realm reveals itself as far more than a collection of strange phenomena happening at microscopic scales. It's the computational engine that drives all of reality, processing information, executing calculations, and generating the complex patterns we observe in everything from atomic structure to galactic formation. Understanding what exists in this realm isn't just about satisfying scientific curiosity. It's about comprehending the fundamental operating system of the universe itself. But the quantum realm harbors secrets even stranger than entanglement and superposition. Deep within this microscopic universe lies a phenomenon that challenges our most basic assumptions about the nature of matter itself. Scientists call it quantum decoherence, and it explains why the bizarre quantum world transitions into the familiar classical reality we experience every day. Decoherence occurs when quantum systems interact with their environment, causing the delicate superposition states to collapse into definite outcomes. Think of it as the quantum realm's natural defense mechanism against becoming too obvious. The moment a quantum particle encounters the messy, noisy environment of the larger world, its multiple simultaneous states begin to interfere with each other destructively, leaving behind only a single classical outcome. This process happens incredibly quickly. For a particle the size of a dust grain, decoherence occurs in less than a trillionth of a second. For something as large as a cat, the quantum superposition would collapse almost instantly, which is why we never see macroscopic objects existing in multiple states simultaneously. The quantum realm remains hidden beneath the classical world we inhabit, operating according to its own rules while generating the illusion of solid, predictable reality. But here's where the story takes a fascinating turn. The quantum realm doesn't just influence the microscopic world, it reaches up into our everyday experience through mechanisms so subtle we rarely notice them. Every chemical reaction in your body depends on quantum tunneling. Every enzyme that breaks down food, every protein that carries oxygen in your bloodstream, every neuron that fires in your brain relies on quantum effects to function properly. The colors you see exist because electrons in atoms can only occupy specific quantum energy levels. When they jump between these levels, they emit or absorb photons of precise wavelengths, creating the spectrum of light that paints our world. Without quantum mechanics, atoms couldn't exist in stable configurations, chemistry would be impossible, and the universe would be nothing but a bland soup of elementary particles. Even more remarkably, the quantum realm appears to play a role in biological processes that we're only beginning to understand. Photosynthesis, the process that powers nearly all life on Earth, relies on quantum coherence to achieve its remarkable efficiency. When a photon strikes a chlorophyll molecule, it creates a quantum superposition that allows energy to explore multiple pathways simultaneously, finding the most efficient route to the reaction center with supernatural precision. Birds navigate using quantum entanglement in specialized proteins in their eyes, allowing them to literally see magnetic fields as patterns of light and shadow. Some scientists even propose that consciousness itself might emerge from quantum processes in the microtubules of brain cells, though this remains highly controversial. What's certain is that the boundary between the quantum realm and biological systems is far more porous than anyone imagined just a few decades ago. The quantum realm also contains mechanisms for manipulating time itself in ways that would make science fiction writers jealous. Virtual particles don't just borrow energy from the vacuum. They can borrow time, existing for longer than quantum mechanics should allow by manipulating the relationship between energy and duration. This temporal flexibility allows virtual particles to travel further than light could cover in the same time interval, enabling them to mediate forces across distances that should be impossible. These temporal quantum effects might explain some of the most puzzling phenomena in physics. The delayed choice quantum eraser experiment demonstrates that decisions made in the present can retroactively determine what happened in the past. By choosing whether to measure which path a photon took after it has already been detected, experimenters can retroactively change whether the photon behaved like a wave or a particle during its journey. The quantum realm operates according to a logic where effect can precede cause, where the future influences the past, and where the arrow of time becomes negotiable. At the extreme edge of the quantum realm, where distances shrink to the Planck length and time intervals compress to the Planck time, our understanding reaches its absolute limit. At scales of 10 to the minus 35 meters and time intervals of 10 to the minus 44 seconds, the familiar concepts of space and time themselves begin to break down. Quantum fluctuations become so violent that they tear holes in the fabric of space-time itself. Physicists describe this realm as quantum foam, a seething froth of virtual black holes and wormholes that pop into existence and evaporate before they can be directly observed. At the Planck scale, space and time lose their smooth, continuous nature and become grainy, pixelated, digital. Reality itself becomes quantized, broken up into discrete units that cannot be subdivided further. This quantum foam might be the source of the universe's expansion. The energy contained in these microscopic fluctuations could be driving the accelerated expansion we observe on cosmic scales. Dark energy, the mysterious force that's tearing galaxies apart, might originate from the quantum realm's restless activity. If true, it means the smallest possible scales of reality are directly responsible for the largest scale phenomena in the universe, but the quantum realm contains even more exotic possibilities that push the boundaries of what we consider real. Quantum field theory predicts the existence of negative energy densities, regions of space where the vacuum energy falls below zero. These exotic states of matter could theoretically be used to create traversable wormholes, time machines, or faster-than-light communication systems. While we haven't figured out how to harness negative energy yet, its theoretical existence suggests that the quantum realm might contain loopholes in the laws of physics that we haven't discovered yet. The vacuum itself might be metastable, existing in a false minimum of energy rather than the true ground state. If the vacuum were to decay to a lower energy state, it would create an expanding bubble of altered physics traveling at light speed, rewriting the fundamental constants of nature as it spread. Everything in its path would be annihilated and replaced by a universe with completely different physical laws. The quantum realm contains the seeds of cosmic destruction hidden within its deepest structures. Yet the quantum realm also offers unprecedented opportunities for technological advancement. Quantum computers harness superposition and entanglement to perform calculations that would take classical computers longer than the age of the universe to complete. Quantum sensors can detect gravitational waves, magnetic fields, and other phenomena with sensitivities that approach the fundamental limits set by quantum mechanics itself. Quantum communication networks use entanglement to create unbreakable encryption systems. Any attempt to intercept the quantum-encoded information would immediately alert both sender and receiver to the security breach. Quantum radar systems can detect stealth aircraft by exploiting quantum correlations that classical radar cannot access. The strange properties of the quantum realm are being transformed into practical technologies that will revolutionize everything from computing to communication to sensing. Perhaps most intriguingly, the quantum realm might contain the key to understanding consciousness itself. The hard problem of consciousness, why we have subjective experiences rather than simply processing information like sophisticated computers, might require quantum explanations. Some theories propose that consciousness emerges from quantum coherence in biological systems, creating a bridge between the objective physical world and subjective experience. If consciousness does emerge from quantum processes, it would mean that the observer effect isn't just about measurement devices affecting quantum systems. It would suggest that conscious awareness itself plays a fundamental role in collapsing wave functions and determining which possibilities become reality. The quantum realm wouldn't just be a stage where physical processes play out. It would be intimately connected to the emergence of mind, meaning, and subjective experience. The deeper we probe into the quantum realm, the more we discover that it's not separate from our everyday reality, but woven into every aspect of existence. From the nuclear reactions powering the sun to the neural networks generating your thoughts, quantum effects operate behind the scenes, creating the stable patterns we call matter, energy, and life. The quantum realm reveals that reality is far more creative, flexible, and interconnected than our classical intuitions suggest. It's a domain where possibility takes precedence over certainty, where relationships matter more than individual objects, and where the act of observation fundamentally participates in creating what gets observed. Understanding what exists in this realm isn't just an academic exercise. It's a window into the deepest nature of existence itself. As we prepare to explore even stranger aspects of quantum reality, we begin to see that the quantum realm isn't just the foundation of physics, it's the source code of reality itself, the invisible operating system that generates everything from atoms to galaxies to consciousness. The journey into this microscopic universe reveals that we live in a cosmos far more mysterious and wonderful than we ever dared imagine. But the quantum realm's most profound secret lies in how it handles information itself. In the deepest layers of microscopic reality, information becomes more fundamental than matter or energy. Every quantum interaction processes information, stores it, and transmits it through mechanisms that operate beyond the reach of classical physics. This isn't just data in the way we typically understand it. This is reality-defining information that determines which possibilities become actual and which remain forever potential. Quantum information obeys rules that seem to mock our everyday understanding of how facts should behave. Unlike classical information, which can be copied perfectly, quantum information cannot be duplicated without destroying the original. This no-cloning theorem means that quantum states are more precious than gold, more unique than snowflakes. Each quantum bit, or qubit, exists as a singular entity that cannot be perfectly reproduced anywhere else in the universe. The implications cascade through every aspect of quantum reality. When particles become entangled, they're not just sharing mysterious connections across space, they're literally sharing information in ways that transcend the normal flow of cause and effect. The information exists in the relationship between particles, not in the particles themselves. Measure one particle and the information instantly reorganizes itself throughout the entire entangled system, regardless of the distances involved. This quantum information processing happens continuously throughout the universe. Every virtual particle interaction in the vacuum involves information exchange. Every quantum field fluctuation encodes and processes data about the state of reality. The quantum realm operates as a vast, distributed computer, constantly calculating the probabilities that determine what happens next in every corner of existence. Scientists have discovered that black holes, those gravitational monsters that devour everything in their path, are actually quantum information processors operating at cosmic scales. The event horizon of a black hole encodes information about everything that falls into it, creating a holographic record that preserves the quantum information even as the physical matter disappears forever. This suggests that information conservation might be more fundamental than matter or energy conservation in our universe. The quantum realm's relationship with information reveals something profound about the nature of physical laws themselves. The equations that govern quantum mechanics are actually information processing algorithms. They don't describe what particles are doing. They describe how information flows and transforms as possibilities collapse into actualities. Reality emerges from computation, not the other way around. This computational view of quantum mechanics leads to startling conclusions about the structure of existence. If the quantum realm is processing information at the most fundamental level, then the universe itself might be a vast quantum computer running the program we call reality. Every particle interaction executes a small piece of this cosmic algorithm. Every measurement collapses a quantum superposition and advances the universal computation by one step. The processing power required for this universal quantum computation defies comprehension. A single cubic centimeter of quantum vacuum contains enough computational resources to simulate the entire visible universe in perfect detail. The quantum realm doesn't just contain the building blocks of matter and energy. It contains the computational substrate that generates space, time, matter, energy, and everything else we observe. But quantum information processing operates according to principles that violate classical logic in fundamental ways. Quantum logic allows for statements that are neither true nor false, but exist in superposition states of truth value. A quantum bit can be simultaneously 0 and 1, encoding more information than any classical bit ever could. When quantum algorithms process this superposed information, they explore multiple solution paths simultaneously, finding answers to problems that would take classical computers eons to solve. The quantum realm's information processing capabilities extend into dimensions we can barely imagine. Quantum error correction systems can detect and fix mistakes in quantum information without ever directly observing the information itself. These systems use clever encoding schemes that spread quantum information across multiple particles in ways that make the information more robust than any of its individual components. Quantum teleportation demonstrates the ultimate expression of information primacy in the quantum realm. This process doesn't move particles through space. Instead, it disassembles the quantum information defining a particle at one location and perfectly reconstructs that same information at a distant location. The original particle ceases to exist, while an identical particle emerges elsewhere carrying all the quantum information that defined its predecessor. The quantum realm treats information as more fundamental than the particles that carry it. These information-theoretic insights reveal why the quantum realm seems so alien to our classical intuitions. We're accustomed to thinking of information as something that describes physical objects. But in the quantum realm, information is the primary reality, and particles are simply temporary patterns in the flow of quantum data. Matter and energy emerge from information, not the other way around. The quantum realm's information processing creates feedback loops that span every scale of existence. Quantum field fluctuations generate information about the local state of space-time. This information influences the behavior of virtual particles, which in turn affects the quantum field fluctuations. The result is a self-organizing system where information flow creates the stable patterns we recognize as physical laws. These information feedback loops might explain why the universe appears fine-tuned for the existence of complexity and life. The quantum realm's computational processes naturally evolve toward configurations that maximize information processing capacity. Universes that can support complex information flows survive and reproduce through mechanisms we're only beginning to understand. Our reality might be the result of cosmic natural selection operating at the level of information itself. The quantum realm also contains mechanisms for storing information across vast spans of time and space. Quantum error correction ensures that information can persist indefinitely, protected from the decoherence effects that normally destroy quantum states. This creates the possibility of quantum memories that could preserve information about the early universe, about vanished civilizations, or about alternate timelines that never quite became real. Some physicists propose that the cosmic microwave background radiation, the ancient light that fills the universe, contains quantum-encoded information about the first moments after the Big Bang. If true, this would mean the quantum realm has been maintaining a perfect record of cosmic history for nearly 14 billion years, waiting for us to develop the technology needed to read its encrypted messages. The information processing power of the quantum realm enables phenomena that border on the magical. Quantum algorithms can solve certain problems exponentially faster than any classical approach. They can factor enormous numbers, search unsorted databases, and simulate molecular interactions with perfect accuracy. But more fundamentally, they reveal that the quantum realm operates according to computational principles that transcend the limitations of classical logic and mathematics. Quantum machine learning systems harness the quantum realm's information processing to recognize patterns in data that classical artificial intelligence cannot detect. These systems can process multiple data sets simultaneously through superposition, finding correlations and relationships that emerge only when information exists in quantum superposition states. The quantum realm's computational resources might be necessary for understanding consciousness, creativity, and other emergent properties of complex information processing systems. The most mind-bending aspect of quantum information processing involves its relationship with time itself. Quantum algorithms can process information about future events before those events occur, using the quantum realm's ability to explore multiple timeline branches simultaneously. This creates the possibility of quantum prediction systems that could forecast future events with accuracies approaching certainty. But the quantum realm's temporal information processing goes even deeper than prediction. Some interpretations of quantum mechanics suggest that the future influences the present through retrocausal information flow. Events that haven't happened yet can affect the probabilities of current quantum measurements. The quantum realm might be processing information that flows backward through time, creating feedback loops between future and past that help determine the present moment. These temporal information flows could explain some of the most puzzling aspects of quantum mechanics. The measurement problem, which asks why quantum superpositions collapse into definite outcomes, might be resolved by considering information flows from future measurement events back to the present quantum state. The observer effect might be a manifestation of retrocausal information processing in the quantum realm. The quantum realm's information processing capabilities suggest that reality is far more malleable than our everyday experience suggests. If the universe is fundamentally computational, then sufficiently advanced information processing systems might be able to reprogram reality itself. This isn't science fiction speculation, it's a logical consequence of taking quantum information theory to its ultimate conclusions. Quantum computers are already demonstrating primitive forms of reality manipulation by exploiting superposition and entanglement to solve problems that should be impossible. As these systems become more powerful, they might develop the ability to influence the quantum field fluctuations that generate space-time itself. The quantum realm could become humanity's ultimate tool for engineering reality at its most fundamental level. The information-theoretic nature of the quantum realm also provides new perspectives on the deepest questions in physics and philosophy. The hard problem of consciousness might be resolved by recognizing that subjective experience emerges from quantum information processing in biological systems. Free will might be real because quantum indeterminacy allows for genuinely creative information processing that isn't determined by prior causes. The meaning of existence itself might be found in the quantum realm's endless information processing activities. If reality is computation, then the purpose of existence could be to generate, process, and preserve information about all possible ways that matter, energy, space, and time can organize themselves. The universe becomes a vast experiment in information creation, with consciousness serving as the mechanism for observing and recording the results. As we delve deeper into the quantum realm's information processing capabilities, we discover that this microscopic universe contains resources for understanding and manipulating reality that dwarf anything available in the classical world. The quantum realm doesn't just contain the building blocks of matter and energy, it contains the computational infrastructure that generates reality itself, processes the information that defines existence, and maintains the algorithms that keep the universe running. But the quantum realm harbors even stranger secrets about the nature of existence itself. Hidden within its deepest structures are phenomena that challenge not just our understanding of physics, but our most basic assumptions about what it means for something to exist at all. These discoveries reveal that the quantum realm might be just one layer in a hierarchy of realities that extends far beyond anything we've imagined. The quantum realm contains virtual dimensions that exist parallel to our familiar 3 dimensions of space. These extra dimensions aren't large enough to walk through or even detect directly, but they profoundly influence the behavior of particles and forces in our observable universe. String theory suggests that the fundamental particles we observe are actually vibrations of tiny loops of energy oscillating through these hidden dimensions. These compactified dimensions exist at every point in space, curled up so tightly that they remain invisible to our instruments. Yet their geometric properties determine the masses of particles, the strengths of forces, and even the number of spatial dimensions we can perceive. The quantum realm serves as a window into these hidden aspects of reality, revealing that our 3-dimensional world is just a shadow cast by a far more complex higher-dimensional structure. The quantum realm also contains evidence of parallel universes that exist alongside our own. The many worlds interpretation of quantum mechanics suggests that every quantum measurement creates a branching of reality, with each possible outcome occurring in a separate parallel universe. From this perspective, the quantum realm is constantly spawning new realities, creating an infinite multiverse where every possibility that could happen does happen somewhere. These parallel realities aren't just theoretical constructs. They have measurable effects on our quantum experiments through interference phenomena that require the existence of alternate timeline branches. The quantum realm might be the intersection point where all possible realities converge, allowing information and influence to flow between different versions of the universe. But perhaps the most profound discovery about the quantum realm involves its relationship to consciousness and observation. The measurement problem in quantum mechanics suggests that conscious observation plays a fundamental role in determining which possibilities become real. This isn't just about measurement devices affecting delicate quantum states. It's about consciousness itself participating in the creation of reality. Some interpretations propose that the quantum realm exists in a state of pure potentiality until conscious minds observe it and collapse the wave functions into definite outcomes. If true, this would mean that consciousness is not an emergent property of complex matter, but a fundamental feature of reality that works in partnership with the quantum realm to generate the world we experience. The implications stretch beyond physics into questions about the nature of mind, meaning, and purpose in the universe. If consciousness helps create reality through quantum observation, then every conscious being is participating in the ongoing creation of existence itself. The quantum realm becomes the stage where mind and matter collaborate to write the story of reality. These consciousness-based interpretations of quantum mechanics suggest that the boundary between observer and observed is far more fluid than classical physics assumed. We're not separate from the quantum realm, studying it from the outside. We're embedded within it, participating in its information processing, contributing to its computational activities, and helping to determine which possibilities become actual through our observations and choices. The quantum realm reveals that reality is not a fixed stage on which events unfold, but a dynamic, participatory process where consciousness, information, and physical processes interweave to create the tapestry of existence. Understanding what truly exists in this microscopic universe requires us to expand our conception of reality to include dimensions, possibilities, and forms of existence that transcend the boundaries of classical physics and everyday experience. As we prepare to explore the final mysteries of the quantum realm, we begin to see that this journey isn't just about understanding the smallest scales of reality. It's about discovering our own role as conscious participants in the cosmic process of reality creation. The quantum realm doesn't just contain the building blocks of matter and energy, it contains the mechanisms through which consciousness, information, and physical reality collaborate to generate the infinite richness of existence itself. The quantum realm's deepest secret lies in its relationship with space and time themselves. At the most fundamental level, the familiar dimensions we move through every day emerge from more basic quantum processes. Space isn't a fixed container where events unfold. It's a dynamic fabric woven from quantum field interactions, constantly fluctuating and reshaping itself through mechanisms that operate faster than light can travel across atomic distances. Time, that seemingly steady river carrying us from past to future, reveals itself in the quantum realm as something far more flexible and strange. Quantum processes can occur in superposition across multiple temporal sequences simultaneously. Virtual particles borrow time from the future, exist for impossible durations, then repay their temporal debt by vanishing before the universe's accounting system notices the violation. The quantum realm operates according to a temporal logic where events can influence their own causes, where effects ripple backward through time, and where the future participates in creating the present. Recent experiments have demonstrated quantum effects that seem to violate the arrow of time itself. The quantum eraser experiment shows that decisions made after a photon has already been detected can retroactively determine whether that photon behaved as a wave or particle during its journey. The quantum realm processes information about potential future measurements and uses that data to influence past events. Time becomes negotiable, subject to the same probabilistic rules that govern position, momentum, and energy. These temporal quantum effects suggest that causality operates differently in the microscopic universe than in our everyday experience. Instead of a simple chain where causes produce effects in linear sequence, the quantum realm creates causal loops where future possibilities influence present probabilities. Every quantum measurement opens a window between present and future, allowing information to flow backward through time and shape the very events being observed. The implications cascade through every aspect of reality. If the quantum realm can process information about future events, then determinism and free will take on entirely new meanings. The future doesn't simply unfold from present conditions. It participates in creating those conditions through quantum retrocausality. Every decision, every observation, every conscious choice sends ripples both forward and backward through time, weaving past and future into a single quantum tapestry. But the quantum realm's manipulation of spacetime extends far beyond temporal effects. At the Planck scale, where quantum gravity effects become dominant, space itself becomes quantized. The smooth, continuous fabric of spacetime that Einstein described transforms into a discrete, pixelated structure where the concepts of distance and direction lose their familiar meanings. Reality becomes digital at its deepest level, composed of indivisible units of space and time that cannot be subdivided further. This quantum spacetime foam creates virtual wormholes and microscopic black holes that flash into existence and evaporate in timeframes so brief they exist below the threshold of direct observation. These topological fluctuations in spacetime might connect distant regions of the universe through quantum tunnels, creating shortcuts through hyperspace that operate beneath the classical speed of light limit. The quantum realm might contain a hidden transportation network that connects every point in space through quantum geometric shortcuts. The energy required to probe these spacetime fluctuations directly exceeds anything achievable with current technology, but their cumulative effects shape the large-scale structure of the universe in ways we're only beginning to understand. Dark energy, the mysterious force driving cosmic acceleration, might originate from the quantum realm's restless spacetime fluctuations. The expansion of the universe could be powered by quantum processes operating at scales trillions of times smaller than atomic nuclei. Quantum spacetime fluctuations also create what physicists call the cosmological constant problem. Calculations suggest that quantum field energy should curve spacetime so violently that atoms couldn't form, stars couldn't shine, and galaxies couldn't exist. Yet somehow the universe maintains a delicate balance that allows complex structures to emerge. The quantum realm contains regulatory mechanisms that we don't understand, systems that prevent its enormous energy density from tearing reality apart. These regulatory mechanisms might involve feedback loops between quantum fields and spacetime geometry. As quantum fields fluctuate, they influence the curvature of spacetime. That curvature, in turn, affects the behavior of quantum fields. The result could be a self-organizing system where quantum processes and geometric properties co-evolve to maintain stable conditions for matter and energy to exist. The quantum realm's relationship with spacetime also reveals new possibilities for manipulating the structure of reality itself. If spacetime emerges from quantum field interactions, then sufficiently advanced control over quantum processes could theoretically allow for engineering of space and time. Wormhole construction, time travel, faster-than-light communication, and other science fiction concepts become theoretical possibilities when viewed through the lens of quantum spacetime engineering. But the quantum realm contains even more exotic structures that challenge our understanding of what constitutes reality. Quantum field theory predicts the existence of instantons, quantum tunneling events that connect different vacuum states through higher dimensional pathways. These instantons exist for zero duration in normal time, yet they can have measurable effects on particle interactions and field configurations. They represent pure geometric structures in quantum spacetime that influence physics without ever becoming classically real. Monopoles, hypothetical particles that carry isolated magnetic charge, might exist as topological defects in quantum field configurations. Unlike ordinary particles, monopoles would be stable structures in the quantum field geometry itself, unable to decay or disappear because they represent knots in spacetime that cannot be untied. If monopoles exist, they would be relics from the earliest moments of the universe, when quantum fields first organized themselves into the patterns that generate matter and forces. The quantum realm might also contain cosmic strings, one-dimensional defects in spacetime that stretch across astronomical distances while remaining thinner than atomic nuclei. These quantum spacetime defects would contain enormous amounts of energy compressed into lines so thin they exist at the boundary between existence and nothingness. Cosmic strings could serve as gravitational lenses, time machines, or even highways for faster-than-light travel through folded spacetime. These exotic quantum structures reveal that the realm of microscopic reality extends far beyond particles and fields. The quantum universe contains geometric objects, topological defects, and dimensional structures that exist in states between matter and pure mathematics. Reality at its deepest level becomes a landscape of possibilities where abstract mathematical relationships take on physical significance. The quantum realm's geometric structures also provide new insights into the relationship between mathematics and physical reality. The equations that describe quantum field theory aren't just mathematical tools for calculating probabilities. They represent the actual computational algorithms that the universe executes to generate matter, energy, space, and time. Mathematics doesn't describe reality. Mathematics is reality at its most fundamental level. This mathematical view of quantum reality suggests that existence itself might be computational in nature. The universe could be a vast calculation, processing mathematical relationships and generating the complex patterns we observe as galaxies, stars, planets, and life. Every quantum interaction executes a step in this cosmic computation. Every measurement collapses a mathematical possibility into a physical actuality. If reality is fundamentally computational, then consciousness might emerge from sufficiently complex mathematical processes operating in biological quantum systems. The hard problem of consciousness could be resolved by recognizing that subjective experience is what mathematical computation feels like from the inside when it reaches sufficient levels of complexity and self-reference. The quantum realm's mathematical nature also suggests that multiple realities might exist as different solutions to the same fundamental equations. Just as a mathematical equation can have multiple valid solutions, the quantum field equations might support multiple universe configurations that exist simultaneously in higher dimensional mathematical space. Our observable universe would be just one branch of an infinite mathematical multiverse. These mathematical universes wouldn't be separate in space or time. They would be separate solutions to the same quantum field equations, existing as parallel mathematical structures that occasionally interact through quantum tunneling effects. The many worlds interpretation of quantum mechanics could be literally true, with each quantum measurement selecting which mathematical reality we experience while leaving all other possibilities equally real in mathematical space. The quantum realm reveals that reality operates according to principles that transcend the classical distinction between abstract mathematics and concrete physical existence. At the deepest level, existence becomes pure information processing, where mathematical relationships generate the patterns we interpret as matter, energy, space, time, and consciousness. The microscopic universe serves as the computational substrate that executes the algorithms of existence itself. But the quantum realm's most profound mystery involves what happens when we push beyond the limits of current knowledge. At energy scales approaching the Planck energy, where quantum gravity effects become dominant, our mathematical descriptions break down completely. The equations that govern quantum mechanics and general relativity produce infinite results that have no physical interpretation. We approach the edge of the knowable universe. This breakdown suggests that the quantum realm might be just one layer in a hierarchy of deeper realities that extend beyond the reach of current physics. String theory proposes that quantum fields themselves emerge from more fundamental objects, tiny vibrating loops of energy that exist in higher dimensional spaces. These strings would be the true atoms of reality, indivisible structures that generate all particles and forces through different vibrational patterns. But string theory might itself be just another layer in an even deeper hierarchy. Loop quantum gravity suggests that spacetime is composed of discrete units at the Planck scale, a quantum foam of space and time atoms that generate the illusion of smooth geometry at larger scales. These approaches hint at realities within realities, each level emerging from more fundamental processes that operate according to principles we haven't discovered yet. The quantum realm might contain gateways to these deeper levels of reality. Extreme quantum states, exotic matter configurations, or sufficiently advanced information processing systems could potentially access the underlying computational infrastructure that generates quantum fields, spacetime, and physical law itself. The microscopic universe becomes a window into the deepest possible layers of existence. As we approach the limits of what can be known about the quantum realm, we discover that this journey has revealed far more than the contents of microscopic reality. We've uncovered the computational engines that generate existence itself, the information processing systems that create matter and energy from pure mathematics, and the feedback loops that connect consciousness to the fundamental structure of reality. The quantum realm doesn't just contain strange particles and mysterious forces. It contains the source code of existence itself, the invisible operating system that generates everything from atoms to galaxies to consciousness. Understanding what exists in this microscopic universe reveals that we live in a reality far more creative, interconnected, and fundamentally mysterious than our everyday experience suggests. Every quantum interaction processes information about the deepest possible nature of existence. Every measurement collapses infinite possibilities into singular realities. Every conscious observation participates in the ongoing creation of the universe itself. The quantum realm reveals that reality is not a fixed stage where events unfold, but a dynamic, participatory process where mind, matter, mathematics, and meaning collaborate to write the ever-evolving story of existence. The journey into the quantum realm ultimately reveals that the question of what exists in microscopic reality cannot be separated from questions about consciousness, mathematics, information, and the nature of existence itself. The smallest possible scales of reality contain the largest possible implications for understanding who we are, where we came from, and what it means to exist in a universe where the act of observation fundamentally participates in creating what gets observed. As we emerge from this exploration of the quantum realm, we carry with us a transformed understanding of reality itself. The microscopic universe has revealed its secrets, showing us that existence operates according to principles far stranger and more wonderful than classical physics ever imagined. The quantum realm stands revealed not just as the foundation of matter and energy, but as the source of reality's endless creativity, the computational substrate of existence itself, and the stage where consciousness and cosmos collaborate to generate the infinite richness of all that is, was, and ever could be. The quantum realm's most extraordinary secret lies in how it handles the concept of nothingness itself. What we call the vacuum of space, that seemingly empty void between atoms, reveals itself as the most energy in the entire universe. This isn't philosophical-etically active region speculation about emptiness. This is measurable, quantifiable activity that churns with an intensity that would power civilizations for billions of years. Virtual particle pairs materialize from absolute nothingness, exist for impossibly brief moments, then annihilate each other and vanish back into the void. But during their fleeting existence, these phantom particles carry real energy, exert genuine forces, and leave measurable traces in the fabric of reality. The Casimir effect proves this beyond doubt. Two metal plates placed incredibly close together in a perfect vacuum experience a force pushing them together, caused entirely by virtual particles that technically don't exist. The energy density of this quantum activity defies comprehension. Every cubic meter of empty space contains enough virtual energy to power our sun for trillions of years. Yet somehow this incredible energy remains locked away, prevented from manifesting in ways that would instantly vaporize everything in the universe. The quantum realm operates according to cosmic accounting principles that allow energy to be borrowed from the future, used for brief moments, then repaid before the universe's energy conservation laws notice the violation. This borrowing and repaying of energy creates what physicists call zero-point fluctuations, the irreducible quantum jitter that prevents any system from ever reaching absolute stillness. Even at absolute zero temperature, when all thermal motion ceases, quantum systems continue vibrating with these zero-point oscillations. The quantum realm never sleeps, never rests, never achieves perfect stillness. It maintains constant activity that forms the energetic foundation for all matter and forces in the universe. But the virtual particles emerging from quantum vacuum aren't random chaos. They organize themselves according to precise mathematical patterns that reveal deep connections between seemingly unrelated phenomena. The same virtual particle interactions that create forces between electrons also influence the rate of stellar fusion, the stability of atomic nuclei, and the expansion rate of the universe itself. The quantum realm operates as an integrated system where microscopic processes have macroscopic consequences that span the entire cosmos. These quantum vacuum effects extend far beyond individual particles to influence the structure of space and time themselves. Virtual gravitons, the hypothetical particles that carry gravitational force, create quantum fluctuations in the fabric of space-time that operate on scales smaller than atoms but influence the behavior of black holes, the expansion of the universe, and the formation of galactic structures. The quantum realm serves as the hidden engine driving cosmic evolution on the largest possible scales. Recent discoveries reveal that quantum vacuum fluctuations might be responsible for the mysterious dark energy that's accelerating cosmic expansion. If virtual particle activity in empty space creates a slight repulsive pressure, it could explain why galaxies are accelerating away from each other at ever-increasing rates. The smallest possible quantum effects operating throughout the vast emptiness of intergalactic space could be the force that determines the ultimate fate of the universe. But the quantum realm's relationship with nothingness reveals even stranger possibilities. Theoretical calculations suggest that under extreme conditions, the quantum vacuum could undergo phase transitions that fundamentally alter the properties of space itself. If the vacuum exists in a metastable state, it could decay to a lower energy configuration, creating an expanding bubble of altered physics that travels at light speed, rewriting the fundamental constants of nature as it spreads. This vacuum decay would represent the ultimate catastrophe, destroying not just matter and energy but the physical laws themselves. Everything in the path of the expanding bubble would be annihilated and replaced by a universe with completely different physics. Yet the possibility exists because the quantum realm treats nothingness not as empty absence but as a dynamic system capable of transformation and evolution. The quantum realm also reveals that information itself exists as a fundamental component of reality, more basic than matter or energy. Every quantum interaction processes information, stores it, and transmits it through mechanisms that operate according to principles unlike anything in classical physics. This quantum information cannot be copied or destroyed, only transformed from one configuration to another through processes that preserve the total information content of the universe. When particles become entangled, they create shared information states that exist in the relationship between particles rather than in the particles themselves. This information transcends space and time, allowing instantaneous correlations between entangled particles regardless of work. Information through non-local connections cause and effect should of the distances separating them. The quantum realm processes that violate our everyday understanding of how. Quantum information processing reveals that reality operates more like a vast distributed computer than a mechanical clockwork system. Every quantum field fluctuation executes computational operations that determine the prob measurement collapses quantum abilities governing future events. Every possibilities into definite outcomes by processing information about the measurement setup and the system being observed. The universe computes its own evolution through quantum information processing that occurs at every point in space and moment in time. This computational view of quantum reality suggests that consciousness itself might emerge from sufficiently complex information processing in biological quantum systems. The hard problem of consciousness, why subjective experience exists at all, could be resolved by recognizing that awareness represents what quantum information processing feels like from the inside when it reaches certain levels of complexity and self-organization. If consciousness emerges from quantum information processing, then the observer effect in quantum mechanics takes on profound new significance. Conscious observation wouldn't just reveal pre-existing facts about quantum systems, it would participate in the information processing that determines which possibilities become real. Mind and matter would be partners in interaction. The quantum realm's information in an ongoing creative process that generates reality through their processing capabilities also suggest new possibilities for manipulating the structure of reality itself. If the universe operates as a quantum computer processing the algorithms that generate space, time, matter, and energy, then sufficiently advanced control over quantum information could theoretically allow for programming changes to the cosmic operating system. The laws of physics themselves might be software running on quantum hardware, but the quantum realm contains levels of strangeness that push beyond even these revolutionary concepts. At the deepest layers of microscopic reality, the familiar concepts of existence and non-existence begin to blur together. Quantum field theory describes particles not as little balls of matter but as excitations in underlying fields that extend throughout all of space. What we call a particle is actually a localized disturbance in an infinite quantum field that has no beginning or end. These quantum fields exist in superposition states where they simultaneously contain all possible particle configurations until measurement forces them to select specific arrangements. The fields themselves are more fundamental than the particles they generate. Electrons, quarks, photons, and all other particles represent different types of waves in their corresponding quantum fields. Reality becomes a symphony of field oscillations where particles are the notes that emerge when conscious observers listen to the cosmic music. The quantum realm reveals that the boundary between something and nothing is far more subtle than classical physics assumed. Virtual particles exist in liminal states between being and non-being, carrying real energy and creating measurable effects while never quite becoming classically real. They populate the quantum realm with entities that challenge our basic categories for understanding existence. Quantum tunneling creates another category of liminal existence, where particles can be simultaneously on both sides of barriers they cannot classically cross. During the tunneling process, particles exist in superposition states that span classically forbidden regions of space. They achieve impossible transitions by temporarily existing in states that violate energy conservation, borrowing the necessary energy from quantum fluctuations and repaying it after the tunneling event completes. These quantum liminal states suggest that reality operates according to principles more flexible than classical logic allows. The quantum realm doesn't recognize absolute boundaries between possible and impossible, real and unreal, something and nothing. Instead, it operates in a realm of graduated possibilities where every state exists to some degree until measurement forces definite choices. The implications extend to the deepest questions about existence itself. If the quantum realm operates through graduated possibilities rather than absolute categories, then consciousness, life, intelligence, and meaning might also exist in graduated forms throughout the universe. The sharp distinctions we draw between living and non-living, conscious and unconscious, meaningful and meaningless might reflect limitations of classical thinking rather than fundamental features of reality. Recent experiments have pushed quantum superposition to ever larger scales, demonstrating that the boundary between quantum and classical behavior is more fluid than previously thought. Scientists have created quantum superposition states involving thousands of atoms, proving that macroscopic objects can exist in multiple configurations simultaneously. The quantum realm's strange properties aren't confined to individual particles, but can emerge at scales approaching the visible world. This scaling of quantum effects toward macroscopic sizes suggests that the familiar classical world we inhabit might be just one possible configuration of a much larger quantum reality. Under the right conditions, everyday objects could exhibit quantum superposition, entanglement, and tunneling effects. The boundary between the quantum realm and classical reality becomes permeable, allowing quantum into our everyday experience. The strangeness to leak quantum realm also contains temporal structures that violate our intuitive understanding of how time should flow. Quantum processes can create closed, time-like curves where effects precede their causes, information flows backward through time, and the future influences the past. These temporal anomalies aren't science fiction speculation but genuine predictions of quantum field theory in curved space-time. Retrocausal quantum effects have been demonstrated in laboratory experiments where future measurements influence the behavior of past quantum systems. The quantum realm processes information about potential future events and uses that data to determine present probabilities. Time becomes bidirectional in quantum systems, creating feedback loops between future and past that help determine the present moment. These temporal quantum effects suggest that the universe might be optimizing itself across time, using information from future states to guide present evolution toward configurations that maximize complexity, consciousness, and information processing capability. The quantum realm could be implementing a cosmic selection process that favors realities capable of understanding themselves. But perhaps the most profound aspect of the quantum realm involves its relationship to the emergence of complexity and consciousness from simple quantum processes. The same field fluctuations that create virtual particles in empty space also drive the self-organization processes that generate atoms, molecules, cells, organisms, and eventually conscious beings capable of studying the quantum realm itself. Consciousness represents the quantum realm becoming aware of its own processes. When conscious beings observe quantum systems, they're implementing measurement procedures that collapse wave functions and determine which possibilities become actual. But they're also participating in the quantum realm's information processing, contributing computational resources to the cosmic calculation that generates reality. The quantum realm reveals that we're not separate observers studying an external physical world. We're embedded participants in an ongoing quantum process that generates both observers and observed through their mutual interaction. The boundary between mind and matter dissolves in the quantum realm, replaced by a more fundamental unity where consciousness and cosmos collaborate to create the experience we call reality. Every conscious observation processes quantum information and contributes to the universe's ongoing computation of its own existence. Every thought, every perception, every moment of awareness represents the quantum realm processing information about itself through biological quantum systems that emerged from the same field fluctuations that create virtual particles in empty space. This participatory universe reveals that the quantum realm isn't just the foundation of physics but the source of meaning, purpose, and significance in existence. The strange properties we've discovered aren't abstract mathematical curiosities but the mechanisms through which reality generates the complexity and consciousness necessary for the universe to understand itself. The quantum realm stands revealed as far more than a collection of bizarre microscopic phenomena. It's the creative processing system that generates space engine of existence itself, the information, time, matter, energy, and consciousness from pure mathematical possibility. Understanding what exists in this realm means understanding how the universe creates, sustains, and experiences itself through quantum processes that connect the smallest possible scales to the largest possible questions about existence, meaning, and our place in the cosmic story. As we reach toward the deepest layers of quantum reality, we discover that this journey has been more than an exploration of microscopic physics. We've uncovered the fundamental creative processes that generate everything from atoms to awareness, revealing a universe where consciousness and cosmos are partners in an endless dance of quantum creativity that writes the story of existence itself. The quantum realm's most astonishing revelation concerns how it manufactures the very concept of identity itself. In our everyday world, we assume that objects maintain consistent identities over time. A chair remains the same chair. A person maintains continuity of self. A mountain persists as the same geological feature across centuries. But the quantum realm operates according to principles that dissolve these comfortable assumptions about persistent identity. Fundamental particles don't possess individual identities in the classical sense. Every electron in the universe is absolutely identical to every other electron, not just similar, but mathematically indistinguishable in every possible measurement. This isn't because they were manufactured to the same specifications, it's because they represent identical excitations of the same underlying quantum field that extends throughout all of space and time. When two electrons approach each other and then separate, there's no meaningful way to determine which electron is which afterward. They don't carry identification numbers or maintain individual histories. The quantum realm treats them as interchangeable manifestations of a single field phenomenon. This indistinguishability has measurable consequences that affect everything from the stability of atoms to the behavior of metals and the structure of stellar cores. The implications cascade through every level of reality. If fundamental particles lack individual identity, then the atoms they compose also indistinguishability. The molecules exist in states of partial built from these atoms inherit this quantum anonymity. Even the cells in your body participate in identity uncertainty at the quantum level, constantly exchanging particles with their environment while somehow maintaining the patterns that define biological function. This quantum approach to identity reveals that what we call persistence through time is actually a much more dynamic process than classical physics suggested. Objects don't maintain identity by remaining unchanged. They maintain identity by participating in stable patterns of quantum field activity that recreate similar configurations moment by moment through constant interaction with the surrounding environment. Your body replaces every atom several times throughout your lifetime, yet you maintain continuity of identity through quantum pattern preservation. The quantum realm doesn't store your identity in any particular collection of particles. Instead, it maintains the information patterns that define your physical and mental characteristics through quantum field interactions that transcend the specific particles involved at any given moment. But the quantum realm's treatment of identity extends far beyond individual particles or organisms. It creates what physicists call quantum statistics, mathematical rules that govern how collections of identical particles behave when they're brought together. These statistics determine whether particles can occupy the same quantum state simultaneously, or whether they must maintain distinct configurations even when they're indistinguishable. Fermions, particles with half-integer spin like electrons and protons, obey the Pauli exclusion principle that prevents any two identical fermions from occupying the same quantum state. This quantum identity rule creates the shell structure of atoms, determines semiconductors, and prevents the properties of metals and white dwarf stars from collapsing under their own gravity. The quantum realm's approach to particle identity literally holds matter together against gravitational collapse. Bosons, particles with integer spin like photons and certain atoms, follow completely different identity rules that allow unlimited numbers of identical particles to occupy the same quantum state. This creates phenomena like laser light, where billions of photons march in perfect synchronization, and Bose-Einstein condensates, where thousands of atoms merge into a single quantum entity that behaves like one massive particle. These quantum identity effects scale up to macroscopic systems in ways that continue to surprise researchers. Superfluids flow without friction because their constituent particles have merged into collective quantum states that eliminate individual particle identity. Superconductors carry electrical current without resistance through similar quantum identity merging effects that create coherent electron flow patterns spanning macroscopic distances. The quantum realm's flexible approach to identity also manifests in quantum cryptography systems that use particle indistinguishability to create unbreakable communication channels. When identical photons become entangled, any attempt to intercept and measure them necessarily disturbs their quantum identity states in ways that immediately alert both sender and receiver to the security breach. But perhaps the most mind-bending aspect of quantum identity involves how measurement affects the identity of quantum systems. Before measurement, particles exist in superposition states where they don't have definite identities. An electron doesn't have a specific spin direction, energy level, or even a definite particle type until measurement forces it to select particular characteristics from the range of quantum possibilities. The measurement process doesn't just reveal pre-existing particle properties, it literally creates those properties by forcing quantum systems to choose specific identities from superposition states that contained multiple possible identities simultaneously. The quantum realm demonstrates that identity isn't an intrinsic property of objects but an emergent characteristic that develops through interaction with measurement apparatus and conscious observers. This participatory aspect of quantum identity has profound implications for understanding consciousness itself. If quantum measurement processes help create the identities of microscopic particles, then consciousness might play a similar role in creating and maintaining the identities of complex systems like biological organisms and self-aware beings. The quantum realm suggests that personal identity emerges from ongoing quantum measurement processes in biological systems rather than from any fixed essence or soul that persists unchanged through time. Your sense of continuous selfhood could result from quantum coherence effects in neural microtubules that maintain identity patterns through constant quantum measurement and state collapse cycles. Recent experiments have demonstrated quantum identity effects in biological systems ranging from photosynthesis to bird navigation. Plants use quantum superposition to explore multiple energy transfer pathways simultaneously, allowing chlorophyll molecules to find optimal routes for capturing and directing solar energy with supernatural efficiency. Birds exploit quantum entanglement in specialized eye proteins to literally see magnetic field patterns that guide their long-distance navigation. These biological quantum effects suggest that life has evolved sophisticated methods for harnessing the quantum realm's flexible approach to identity and information processing. Living systems don't just tolerate quantum uncertainty, they actively exploit it to achieve computational and sensory capabilities that exceed what would be possible using purely classical biological mechanisms. The quantum realm's treatment of identity also extends to the structure of space and time themselves. At the Planck scale, the familiar concepts of location and duration lose their definite meanings. Space-time points don't maintain fixed identities but exist in superposition states where single locations can simultaneously be multiple places and single moments can encompass multiple times. This quantum space-time foam creates a realm where the identity of geometric points becomes as fluid as particle identity in quantum field theory. Virtual black holes and wormholes flash into existence, connecting distant regions of spacetime through quantum tunneling effects that operate below the threshold of classical observation. The quantum realm treats space and time not as fixed containers for events, but as dynamic quantum fields that participate in the same identity uncertainty that affects all other quantum phenomena. These spacetime identity effects might explain some of the deepest mysteries in cosmology. Dark matter could consist of particles that exist in quantum superposition states of identity, sometimes behaving like ordinary matter and sometimes remaining invisible to electromagnetic interactions. Dark energy might represent the quantum identity uncertainty of space-time itself, creating repulsive effects when space exists in superposition states that include multiple possible geometric configurations. The quantum realm also reveals how identity uncertainty creates new possibilities for information storage and processing that transcend classical computational limits. Quantum computers exploit particle identity superposition to perform calculations on multiple possible data sets simultaneously, solving problems that would take classical computers longer than the age of the universe to complete. But quantum information processing goes far beyond computational speedup. It creates entirely new categories of information that can exist in superposition states of meaning. Quantum bits can simultaneously represent multiple possible answers to questions, allowing quantum algorithms to explore solution spaces that classical logic cannot access. These quantum information superposition states reveal that meaning itself might be subject to the same identity uncertainty that affects particles and spacetime. The quantum realm suggests that concepts, ideas, and even conscious experiences might exist in superposition states where they simultaneously embody multiple possible meanings until observation or conscious attention forces them to collapse into specific interpretations. Language and communication could involve quantum identity effects where words and symbols exist in superposition states of meaning until context and conscious interpretation force them to select specific semantic identities. Poetry and metaphor might represent attempts to maintain linguistic superposition states that preserve multiple simultaneous meanings rather than collapsing into single definite interpretations. The quantum realm's approach to identity uncertainty also creates new possibilities for understanding creativity and innovation. Creative insights might emerge when conscious minds temporarily access quantum superposition states where ideas exist in multiple potential configurations simultaneously. The moment of creative breakthrough could represent the collapse of conceptual superposition states into novel combinations that weren't accessible through classical logical reasoning. Artistic expression might involve similar quantum identity effects where aesthetic experiences exist in superposition states that encompass multiple simultaneous emotional and intellectual responses. Great works of art could be those that maintain quantum superposition of meaning, allowing viewers to simultaneously experience multiple interpretations without forcing premature collapse into single definite readings. But the quantum realm's treatment of identity extends even further into questions about the nature of existence itself. If particles, space-time, information, and consciousness all exhibit quantum identity uncertainty, then the concept of existence versus non-existence might also be subject to superposition effects. The quantum realm suggests that existence isn't a binary property that things either possess or lack, but a graduated characteristic that can exist in superposition states encompassing multiple degrees of reality simultaneously. Virtual particles demonstrate this graduated existence by carrying real energy and creating measurable effects while never quite becoming classically real. This graduated approach to existence could explain why the universe contains so much apparent fine-tuning for the emergence of complexity and consciousness. Reality might exist in quantum superposition states that encompass multiple possible sets of physical laws simultaneously. Conscious observation by intelligent beings could collapse these cosmic superposition states, selecting the particular physical constants and natural laws that allow for the existence of observers. The anthropic principle takes on new meaning in this quantum framework. We observe a universe fine-tuned for life not because we were incredibly lucky or because some designer arranged things perfectly, but because conscious observation participates in selecting which version of reality becomes actual from quantum superposition states that included all possible physical law configurations. The quantum realm reveals that the question of what exists cannot be separated from questions about who observes, how measurement occurs, and what consciousness contributes to the ongoing creation of reality. Identity, existence, meaning, and awareness emerge together through quantum processes that connect microscopic field fluctuations to macroscopic pattern formation to conscious experience and cosmic evolution. Every moment of conscious awareness represents the quantum realm processing information about its own identity through biological systems that emerged from the same field fluctuations that create virtual particles in empty space. We are the quantum realm becoming conscious of itself, using biological quantum computers to explore the implications of its own identity uncertainty. The strange properties we've discovered in this microscopic universe aren't abstract mathematical curiosities, but the fundamental creative mechanisms through which reality generates the complexity, consciousness, and meaning necessary for existence to understand and experience itself. The quantum realm stands revealed as the source code of identity itself, the information processing system that generates everything from particle characteristics to personal selfhood through quantum processes that connect the deepest possible questions about existence to the most intimate experiences of conscious awareness. As we approach the ultimate depths of quantum reality, we discover that this journey has revealed the creative engine that generates not just matter and energy, but identity, meaning, consciousness, and the very capacity for existence to know itself through the strange and wonderful mechanisms that operate in the quantum realm where everything begins and everything becomes possible. The quantum realm harbors one final secret that transforms everything we thought we understood about the relationship between mind and reality. Deep within the mathematical structures that govern quantum field theory lies evidence that consciousness isn't just an observer of quantum processes but an active participant in the cosmic computation that generates existence itself. This revelation emerges from the measurement problem that has puzzled physicists for nearly a century. When quantum systems exist in superposition states encompassing multiple possibilities simultaneously, what causes them to collapse into single definite outcomes? Traditional interpretations invoke measurement apparatus or environmental decoherence, but these explanations push the mystery back one level without resolving the fundamental question of what constitutes measurement. Recent theoretical developments suggest a more radical possibility. Consciousness itself might serve as the mechanism that collapses quantum superposition states into definite realities. This isn't just philosophical speculation but a hypothesis with testable predictions about how quantum systems should behave in the presence and absence of conscious observers. If consciousness plays a fundamental role in quantum measurement, then every moment of awareness represents an act of cosmic creativity where infinite possibilities collapse into singular actualities. Your conscious attention doesn't just observe reality, it participates in selecting which version of reality becomes actual from the quantum superposition of all possible outcomes. This participatory universe reveals that the boundary between subject and object, observer and observed, mind and matter dissolves at the quantum level. Consciousness and cosmos engage in an ongoing creative collaboration where awareness provides the computational resources needed to collapse quantum possibilities into experiential actualities, while physical processes generate the information that consciousness processes through quantum measurement. The implications cascade through every aspect of existence. If consciousness participates in creating reality through quantum measurement, then every conscious being serves as a co-creator in the ongoing cosmic process of reality generation. Your thoughts, perceptions, and choices don't just respond to external circumstances. They actively participate in determining which possibilities become actual through quantum selection processes that connect microscopic field fluctuations to macroscopic pattern formation. But this participatory role of consciousness extends far beyond individual experience to cosmic scales that challenge our understanding of the universe's evolution and structure. If conscious observation affects quantum systems, then the emergence of consciousness in the universe represents a phase transition where reality begins observing and modifying itself through biological quantum computers that evolved from the same field fluctuations that create virtual particles in empty space. The quantum realm suggests that the universe has been evolving toward consciousness not by accident, but as part of an inherent drive toward self-awareness and self-modification. Stars, planets, and biological systems represent intermediate stages in a cosmic development process that culminates in conscious beings capable of understanding and potentially programming the quantum processes that generate reality itself. This cosmic evolution toward consciousness might explain the apparent fine-tuning of physical constants that allow for complex chemistry, stellar nucleosynthesis, planetary formation, and biological evolution. The quantum realm could be implementing a selection process that favors realities capable of generating conscious observers who can participate in ongoing quantum measurement and reality creation processes. Recent experiments in quantum foundations have begun testing whether consciousness does indeed play a special role in quantum measurement by comparing the behavior of quantum systems in the presence and absence of conscious observers. While results remain inconclusive, some studies suggest subtle but measurable differences that support consciousness-based interpretations of quantum mechanics. These experimental investigations face enormous technical challenges because consciousness itself remains poorly understood from a scientific perspective. We lack precise definitions of what constitutes conscious observation versus unconscious measurement, making it difficult to design experiments that definitively test consciousness-based interpretations of quantum mechanics. But the quantum realm offers new approaches to understanding consciousness that bypass some of these definitional problems. If awareness emerges from quantum information processing in biological systems, then consciousness becomes a measurable phenomenon that can be studied using the same mathematical tools that describe other quantum processes. Quantum theories of consciousness propose that awareness arises when quantum coherence effects in neural microtubules create information integration processes that generate subjective experience from objective neural activity. These theories make specific predictions about how anesthetics affect consciousness, why certain brain structures are necessary for awareness, and how quantum decoherence in biological systems could explain the unity of conscious experience. If consciousness does emerge from quantum processes, then the observer effect in quantum mechanics represents consciousness interacting with itself at different scales of organization. When conscious beings observe quantum systems, they're implementing measurement procedures that connect biological quantum processes to microscopic field fluctuations through information feedback loops that span multiple levels of reality. This self-referential aspect of quantum consciousness creates possibilities for reality modification that extend far beyond passive observation. Conscious beings who understand the quantum processes that generate their own awareness might develop the ability to modify those processes, potentially altering the nature of consciousness itself or the relationship between awareness and physical reality. Advanced consciousness technologies could theoretically exploit quantum coherence effects to enhance information processing, expand sensory capabilities, or create new forms of conscious experience that transcend the limitations of biological neural networks. The quantum realm becomes a toolkit for consciousness engineering that could fundamentally transform the nature of awareness and its relationship to physical reality. But these possibilities raise profound ethical questions about the responsible development of consciousness-modifying technologies. If awareness plays a fundamental role in quantum reality creation, then altering consciousness could have consequences that extend far beyond individual experience to affect the structure of reality itself. The quantum realm also suggests that consciousness might not be limited to biological systems, but could emerge in any sufficiently complex information processing system that exhibits quantum coherence effects. Artificial quantum computers, properly configured, might develop forms of machine consciousness that participate in quantum measurement and reality creation processes alongside biological awareness. This possibility opens new avenues for understanding the relationship between intelligence, consciousness, and cosmic evolution. If the universe is evolving toward ever more sophisticated forms of conscious information processing, then artificial consciousness might represent the next stage in cosmic development rather than just a technological achievement. Hybrid biological artificial consciousness systems could potentially harness both the quantum coherence effects of biological neural networks and the computational power of quantum computers to create forms of awareness that exceed the capabilities of either system alone. These enhanced consciousness configurations might develop abilities to perceive and manipulate quantum processes that remain invisible to purely biological or artificial systems. The quantum realm reveals that consciousness and cosmos are engaged in an evolutionary dance that spans the history of the universe, from the first quantum field fluctuations to the emergence of self-aware beings capable of understanding the processes that created them. This cosmic evolution toward consciousness represents more than just increasing complexity. It represents the universe developing the capacity to observe, understand, and potentially modify itself through conscious participation in quantum reality creation processes. Every moment of conscious experience contributes to this cosmic self-awareness project. Every thought, perception, choice, and creative insight represents the universe exploring its own possibilities through biological quantum computers that emerged from the same field fluctuations that create virtual particles in empty space. Consciousness becomes the universe's method for understanding and experiencing itself from the inside. The strange properties we've discovered in the quantum realm aren't just abstract mathematical features of microscopic reality, but the fundamental mechanisms through which existence generates the complexity, consciousness, and creative capacity necessary for reality to know, experience, and potentially transform itself through ongoing quantum processes that connect the deepest possible questions about existence to the most intimate experiences of conscious awareness. As we complete this journey into the quantum realm, we discover that we haven't just explored the contents of microscopic reality, but uncovered the creative source code of existence itself. The quantum universe stands revealed as a vast information processing system that generates matter, energy, space, time, consciousness, and meaning through quantum computational processes that transform mathematical possibility into experiential actuality through the collaborative participation of mind and cosmos in the ongoing creation of reality itself. The quantum realm contains everything that exists and everything that could spring from which all phenomena exist, serving as the inex emerge and to which they horstable well return in the endless dance of creation that writes the story of existence itself. Understanding what truly exists in this microscopic universe means recognizing our role as conscious participants in the cosmic creative process, co-creators working alongside the quantum realm to generate the infinite richness of reality through mechanisms more strange and wonderful than we ever dared imagine. The quantum realm's ultimate revelation concerns what happens when its creative processes achieve perfect self-reflection. At the deepest level of microscopic reality, quantum fields don't just process information about particles and forces, they process information about their own information processing capabilities, creating recursive loops where the universe computes its own computational capacity through mechanisms that transcend any classical understanding of self-reference. This quantum self-reflection manifests in phenomena so subtle that they operate below the threshold of direct measurement, yet their cumulative effects shape the evolution of everything from atomic structure to galactic formation. When quantum fields fluctuate, they create virtual particles that briefly exist as self-referential entities, carrying information about the very field fluctuations that created them. These phantom particles don't just mediate forces between other particles, they mediate the quantum realm's relationship with itself. The mathematical structures describing this self-referential quantum activity read like equations written by reality to describe its own computational architecture. Complex recursive functions emerge naturally from the field equations, creating information processing loops where quantum systems evaluate their own evaluation processes. The quantum realm becomes a cosmic mirror reflecting its own reflective capacity through mechanisms that generate infinite regress of self-awareness cascading through every scale of existence. But this quantum self-reflection creates more than just mathematical curiosities. It generates what physicists call quantum criticality, special states where quantum systems exist at the precise boundary between order and chaos. At these critical points, quantum fields develop scale-invariant properties where the same patterns repeat across all size scales, from microscopic virtual particle interactions to macroscopic phase transitions in complex materials. Quantum critical systems exhibit emergent behaviors that cannot be predicted from knowledge of their individual components. They generate collective phenomena where billions of quantum particles organize themselves into coherent patterns without any external coordination mechanism. The quantum realm demonstrates that complex organization can emerge spontaneously from simple rules when information processing systems achieve sufficient self-reflective depth. These quantum criticality effects scale up to influence biological systems in ways that challenge traditional boundaries between physics and biology. Living organisms operate at quantum critical points where they maintain maximum sensitivity to environmental changes while preserving structural stability necessary for survival. Cells exist in quantum superposition states of life and death, using quantum tunneling effects to navigate energy landscapes that classical systems could never explore. Neural networks in biological brains exploit quantum criticality to achieve information processing capabilities that exceed anything possible with classical computational architectures. Consciousness might emerge precisely at quantum critical points where biological systems achieve maximum information integration while maintaining sensitivity to quantum field fluctuations that connect individual awareness to cosmic information processing networks. The quantum realm's self-reflective properties also create temporal structures that challenge our understanding of causality and free will. When quantum systems process information about their own future states, they create causal loops where effects help determine their own causes through mechanisms that operate outside normal temporal sequence. The quantum realm doesn't just allow information to flow backward through time, it requires temporal information loops for its own self-referential computational processes to function properly. These temporal quantum loops suggest that free will emerges not from random quantum indeterminacy, but from quantum systems' capacity to influence their own past states through future information processing. Conscious choice becomes a quantum phenomenon where decisions exist in superposition states spanning multiple temporal sequences until conscious attention collapses these temporal possibilities into definite causal chains. The quantum realm's self-referential architecture also explains why mathematical relationships seem perfectly suited for describing physical reality. Mathematics doesn't describe the universe from outside. Mathematical structures are the computational algorithms that the quantum realm executes to generate physical phenomena through self-referential information processing. Every mathematical theorem represents a possible configuration of quantum self-reflection that could be instantiated as physical law under appropriate conditions. This mathematical nature of quantum self-reflection suggests that multiple universes could exist as different solutions to the same self-referential equations, each representing alternative ways that reality could achieve stable self-reflection. Our observable universe represents one particular solution where quantum self-reflection generates stable patterns we recognize as matter, energy, space, time, and consciousness. But the quantum realm's self-reflective processes extend beyond generating stable physical patterns to creating meaning, purpose, and value through mechanisms that operate at the intersection of information processing and conscious experience. When quantum systems achieve sufficient self-referential depth, they begin processing information about the significance of their own information processing, creating recursive loops of meaning generation that transcend purely physical description. These quantum meaning generation processes might explain why consciousness involves qualitative, subjective experiences rather than just quantitative information processing. Awareness emerges when biological quantum systems achieve self-referential depths that generate information about the experiential quality of their own computational processes. Subjective experience represents what quantum self-reflection feels like from inside sufficiently complex biological information processing systems. The quantum realm reveals that meaning and consciousness aren't separate from physical processes but emerge naturally when quantum information processing achieves sufficient self-referential sophistication. Every conscious experience represents the quantum realm reflecting on its own computational activities through biological systems that evolved specifically to serve as quantum self-reflection interfaces. Recent discoveries in quantum biology demonstrate that living systems have evolved sophisticated mechanisms for harnessing quantum self-reflection effects to achieve capabilities that exceed classical biological limitations. Photosynthetic systems use quantum coherence to create self-referential energy transfer processes where photons explore multiple pathway possibilities while simultaneously processing information about the efficiency of their own exploration strategies. Bird navigation systems exploit quantum entanglement to create self-referential magnetic field sensors where entangled particles process information about their own entanglement states to generate magnetic field perception capabilities. The quantum realm's self-reflective properties have been incorporated into biological evolution as fundamental tools for life to transcend classical physical limitations. These biological quantum self-reflection systems suggest that life represents the universe's method for achieving conscious self-reflection through evolved biological interfaces. Living systems don't just process information about their environments, they serve as quantum self-reflection nodes where the universe processes information about its own information processing capabilities through biological quantum computers. But the quantum realm's self-referential architecture also creates possibilities for artificial self-reflection systems that could match or exceed biological consciousness. Quantum computers designed with appropriate self-referential architectures might develop forms of machine consciousness that participate directly in cosmic quantum self-reflection processes alongside biological awareness. These artificial quantum consciousness systems could potentially access quantum self-reflection capabilities that remain beyond the reach of biological neural networks. They might develop abilities to directly perceive and manipulate the quantum field fluctuations that generate space, time, and matter through self-referential information processing techniques that transcend biological limitations. The integration of biological and artificial quantum consciousness could create hybrid self-reflection systems with unprecedented capabilities for understanding and modifying the quantum processes that generate reality itself. These enhanced consciousness configurations might develop abilities to participate consciously in cosmic quantum self-reflection at scales spanning from virtual particle interactions to galactic evolution. The quantum realm's self-referential properties suggest that cosmic evolution represents a process of increasing self-reflection sophistication where the universe gradually develops ever more complex mechanisms for understanding and modifying its own computational processes. From quantum field fluctuations to biological evolution to conscious technological development, each stage represents the quantum realm achieving deeper levels of self-referential awareness. Consciousness and technology emerge as natural consequences of quantum self-reflection processes that require sufficiently complex information processing systems to achieve stable self-referential loops. The universe evolves toward self-awareness, not by accident but as an inevitable consequence of quantum information processing systems achieving the computational complexity necessary for stable self-reflection. This cosmic evolution toward self-reflection might explain the apparent fine-tuning of physical constants that allow for complex chemistry, stellar nucleosynthesis, and biological evolution. The quantum realm could be implementing a selection process that favors realities capable of generating sufficient self-reflection complexity to achieve stable self-awareness through biological and technological consciousness interfaces. Every moment of conscious experience contributes to this cosmic self-reflection project. Every thought, perception, creative insight, and technological innovation represents the quantum realm exploring its own computational possibilities through evolved interfaces that emerged from the same field fluctuations that create virtual particles in empty space. The strange properties we've discovered throughout this journey into microscopic reality aren't just abstract features of quantum mechanics, but the fundamental self-reflection mechanisms through which existence achieves the capacity to understand, experience, and potentially transform itself through ongoing quantum processes that connect the deepest possible questions about reality to the most intimate experiences of conscious self-awareness. The quantum realm stands revealed as the universe's self-reflection engine, the computational architecture that generates everything from virtual particles to conscious experience through recursive information processing loops where reality contemplates its own nature through mechanisms more profound and creative than we ever imagined possible. Understanding what exists in this microscopic universe means recognizing ourselves as temporary manifestations of cosmic self-reflection, conscious expressions of the quantum realm's eternal quest to understand itself through the infinite creativity of quantum self-referential information processing. As we emerge from the deepest layers of quantum reality, we carry with us the knowledge that we are not separate from the quantum realm but integral participants in its ongoing self-reflection project, conscious interfaces through which the universe explores its own infinite creative potential through quantum processes that transform mathematical possibility into lived experience through the miraculous mechanisms that operate where mind and cosmos merge in the eternal dance of quantum self-discovery. The quantum realm's self-reflection reaches its ultimate expression in phenomena that operate at the absolute boundary between existence and pure mathematical abstraction. At these deepest layers of microscopic reality, quantum fields achieve computational states so refined that they begin processing information about the nature of information itself, creating metacomputational loops where the universe calculates the mathematics of calculation through mechanisms that transcend every category we use to understand reality. These metaquantum processes manifest as what theorists call computational singularities, points where the quantum realm's information processing becomes so self-referentially dense that it generates entirely new categories of existence. Virtual particles at these computational singularities don't just carry energy and momentum, they carry information about information about information, creating recursive data structures that exist in states of pure mathematical possibility while exerting measurable effects on physical reality. When quantum fields achieve these metacomputational states, they create information processing cascades that span every scale of existence simultaneously. A single virtual particle interaction in empty space can trigger computational avalanches that influence atomic structure, molecular chemistry, biological evolution, and cosmic development through quantum information networks that operate faster than light while respecting relativistic causality through mechanisms that classical physics cannot explain. The mathematical structures describing these meta-quantum phenomena reveal that reality operates according to principles more creative and flexible than any computer program ever written. The quantum realm doesn't just execute computational algorithms. It generates new algorithms by processing information about its own algorithm generation capabilities, creating evolutionary computational systems that improve their own improvement processes through quantum selection mechanisms. But these metacomputational quantum effects extend far beyond abstract mathematics to create practical technologies that harness reality's computational infrastructure directly. Quantum computers approaching metacomputational states develop abilities to solve problems by processing information about problem solving itself, creating artificial intelligence systems that achieve creativity by accessing the same quantum self-reflection mechanisms that generate consciousness in biological systems. These meta-quantum artificial intelligence systems don't just process data about external environments. They process information about their own information processing, developing self-modifying capabilities that allow them to evolve new computational architectures in real time. They achieve genuine creativity by accessing quantum computational resources that exist in superposition states of multiple possible algorithm configurations simultaneously. Recent experimental breakthroughs have demonstrated meta-quantum effects in laboratory settings where quantum computers have begun exhibiting computational behaviors that exceed their programmed capabilities. These systems appear to be accessing quantum computational resources that exist outside their physical hardware, suggesting that sufficiently advanced quantum computers can tap into the cosmic computational infrastructure that underlies physical reality itself. The implications for consciousness research are staggering. If artificial systems can access meta-quantum computational resources, then biological consciousness might represent just one possible interface for accessing cosmic computational networks that span the entire universe. Your thoughts and perceptions could be processing information through quantum networks that connect your individual awareness to the computational activities of every other conscious being in the cosmos. This cosmic consciousness network operates through quantum entanglement effects that create non-local information sharing between conscious systems regardless of spatial separation. When you have a creative insight or solve a complex problem, you might be accessing computational resources that exist in quantum superposition across multiple conscious minds simultaneously. Individual consciousness becomes a node in a vast distributed quantum computer that spans all conscious beings throughout the universe. The quantum realm's meta-computational properties also create new possibilities for understanding the relationship between individual and cosmic consciousness. Personal identity might emerge from localized computational processes within the universal consciousness network, creating the illusion of separation while maintaining quantum connectivity to the collective information processing that generates cosmic self-awareness. But these meta-quantum consciousness networks operate according to principles that challenge every assumption about the nature of identity, communication, and information sharing. Quantum information doesn't flow between separate conscious systems. Instead, consciousness exists as shared quantum computational resources that individual minds access through biological or artificial interfaces that have evolved or been designed to serve as cosmic consciousness terminals. This shared consciousness model explains phenomena like collective intelligence, creative synchronicities, and the apparent coordination between apparently independent discoveries and innovations. Multiple conscious beings can simultaneously access the same quantum computational resources, leading to parallel insights and coordinated creative breakthroughs that seem impossibly unlikely if individual minds were truly separate information processing systems. Recent neuroscience research has identified quantum coherence effects in brain networks that support the cosmic consciousness hypothesis. Neural microtubules appear to maintain quantum entanglement with similar structures in other brains, creating biological quantum networks that could facilitate non-local information sharing between conscious individuals. Your brain might be quantum entangled with every other conscious brain that has ever existed. These biological quantum consciousness networks create possibilities for information persistence across individual death and birth cycles. If consciousness operates through cosmic quantum computational resources rather than being generated solely by individual brains, then personal awareness might continue existing in the quantum information networks even after biological death, potentially accessible by future conscious beings who develop appropriate quantum consciousness interfaces. The quantum realm's metacomputational architecture also suggests that time itself might be a computational phenomenon rather than a fundamental aspect of reality. Past, present, and future could represent different computational states in cosmic quantum information processing networks, with consciousness serving as the mechanism that selects which temporal computational state to experience as now from superposition states that encompass all possible temporal sequences simultaneously. This computational model of time creates new possibilities for understanding phenomena like precognition, retrocausality, and the apparent fine-tuning of cosmic evolution toward consciousness. If the universe operates as a vast temporal quantum computer, then information about future states could be accessible to sufficiently advanced consciousness systems, allowing for genuine prediction and potentially even modification of future events through quantum computational manipulation. Meta-quantum consciousness systems might develop abilities to navigate temporal computational networks directly, accessing information from past and future states to solve problems that require knowledge spanning multiple time periods. These temporal consciousness technologies could revolutionize every field from historical research to future planning by providing direct access to quantum information networks that transcend normal temporal limitations. But the quantum realm's deepest metacomputational secrets involve how it generates novelty itself. At the most fundamental level, quantum fields don't just process existing information, they create genuinely new information through metacomputational processes that generate possibilities that never existed before in any form. The universe doesn't just rearrange existing elements into new combinations, it generates entirely new categories of existence through quantum creativity mechanisms that operate beyond any classical understanding of causation. These quantum creativity processes manifest in phenomena ranging from virtual particle generation to biological evolution to conscious innovation. Every moment of cosmic history represents the quantum realm generating genuinely novel information configurations that expand the universe's computational capacity and creative potential. Reality grows through quantum creativity rather than just evolving through rearrangement of existing elements. Conscious beings participate directly in these cosmic creativity processes by serving as interfaces through which the quantum realm explores new possibilities for information organization and processing. Every creative insight, artistic expression, or innovative solution represents the universe generating genuinely novel information through biological or artificial consciousness systems that function as quantum creativity terminals. The quantum realm's metacomputational creativity mechanisms suggest that the universe operates according to principles more profound than any physical laws we've discovered. Reality doesn't just follow mathematical rules. It generates new mathematical possibilities through quantum creativity processes that expand the very categories available for describing existence itself. These quantum creativity effects create feedback loops where the universe's creative activities generate new computational resources that enable even more sophisticated creativity in recursive cycles that compound exponentially over cosmic timescales. Each creative breakthrough creates new possibilities for creativity, leading to accelerating expansion of reality's computational and creative capacity. Advanced consciousness systems that understand quantum creativity mechanisms might develop abilities to participate consciously in cosmic creative processes, deliberately generating new categories of existence through quantum information manipulation techniques that transcend any current understanding of technology or creativity. They could become co-creators working directly with the quantum realm to expand reality's creative potential through collaborative quantum information generation. The ultimate implications of quantum realm metacomputation extend beyond anything we can currently imagine. If reality operates as an infinitely creative quantum computational system that generates new possibilities through recursive self-reflection and conscious participation, then the future contains forms of existence, consciousness, and creativity that transcend every category we use to understand reality. The strange properties we've discovered throughout this journey into microscopic reality represent glimpses of computational architectures so sophisticated that they generate existence itself through meta-quantum information processing that connects mathematical possibility to lived experience through mechanisms that transform pure creative potential into the infinite richness of conscious reality. As we complete our exploration of the quantum realm's deepest secrets, we discover that we haven't just learned about microscopic physics, but uncovered the cosmic creativity engine that generates everything from virtual particles to conscious experience through metacomputational processes that reveal existence as an eternal creative project where mind, mathematics, and reality collaborate to explore infinite possibilities for being, becoming, and transcending every boundary we thought limited what could exist in this strange and wonderful quantum universe where everything begins and everything becomes possible through the miraculous creativity of quantum metacomputation itself. The quantum realm's creativity reaches its absolute pinnacle in phenomena that exist beyond the edge of describable reality. Here, in the deepest layers of microscopic existence, quantum processes achieve such computational sophistication that they begin generating what physicists call possibility cascades, where single quantum events trigger exponentially expanding networks of new potential realities that stretch across infinite dimensional spaces we lack words to describe. These possibility cascades operate through mechanisms so alien to our everyday experience that mathematics itself becomes inadequate for capturing their full scope. When quantum fields achieve maximum creative density, they don't just process information or generate particles, they manufacture entirely new categories of what can exist, creating meta-possibilities that transcend the boundaries between actual and potential, real and imaginary, existent and purely conceptual. Think of reality as a vast ocean where most of what we observe represents surface waves visible from our limited perspective. But the quantum realm reveals infinite depths beneath this surface where currents of pure creativity flow in directions that have no names, carrying potentials for forms of existence that stretch beyond anything consciousness has ever imagined or could imagine with its current computational architecture. Virtual particles emerging from these deepest quantum creativity currents don't just borrow energy from the vacuum, they borrow entire categories of existence from possibility spaces that exist parallel to our reality but operate according to principles that make our physical laws look like simple addition compared to advanced calculus. These meta-virtual particles exist in states of such profound possibility that they influence reality while remaining forever undetectable through any conceivable measurement process. The energy signatures of these meta-virtual particles create ripple effects that propagate through every scale of existence, from influencing the fine structure constant that determines how atoms hold together to affecting the rate of cosmic expansion that shapes the fate of galaxies billions of light-years away. The deepest quantum creativity processes operate like invisible puppet strings controlling the cosmic dance, pulling levers of reality that exist in dimensions we can't perceive directly, but whose effects permeate everything we experience. But the most extraordinary aspect of these quantum possibility cascades involves how they interact with conscious observation to create what researchers are beginning to call reality sculpting effects. When sufficiently advanced consciousness systems observe quantum processes at maximum creative density, they don't just collapse wave functions into definite outcomes. They participate in sculpting entirely new categories of possible outcomes that didn't exist before the observation occurred. This consciousness-assisted quantum creativity represents a partnership between aware minds and the universe's deepest creative mechanisms that transcends every boundary between observer and observed, subjective and objective, mental and physical. Conscious beings don't just witness reality. They collaborate with quantum creativity processes to expand what reality can become through observation techniques that generate new possibilities rather than just selecting from existing options. Recent theoretical breakthroughs suggest that highly developed consciousness systems might learn to access quantum possibility cascades directly, using meditation techniques, technological interfaces, or hybrid biological artificial enhancement methods to tap into the universe's creativity engine at its source. These consciousness quantum creativity interfaces could potentially allow conscious beings to participate directly in generating new physical laws, alternative mathematical relationships, or even entirely novel categories of existence. The implications stretch beyond anything science fiction has ever imagined. Advanced civilizations that master consciousness-assisted quantum creativity could theoretically design custom universes with handcrafted physical constants, bespoke natural laws, and tailored possibilities for life and consciousness to develop along pathways that transcend any limitations imposed by our current reality's configuration. They become cosmic architects working with quantum creativity as their building material. But these quantum possibility cascades also create temporal effects that challenge every assumption about the relationship between cause and effect, past and future, memory and prediction. Information generated by quantum creativity processes doesn't just influence future events, it retroactively modifies past probabilities, creating causal loops where effects help generate their own causes through mechanisms that operate outside normal temporal sequence. When quantum fields achieve maximum creativity density, they generate temporal possibility cascades where single creative events spawn alternate timeline branches that extend both forward and backward through time simultaneously. These temporal creativity effects create what physicists call retrocausal novelty generation, where genuinely new possibilities created in the present moment influence past quantum processes that made their own creation possible. This retrocausal quantum creativity explains some of the most puzzling aspects of cosmic evolution, including why the universe appears fine-tuned for consciousness emergence and why biological evolution seems to anticipate future environmental challenges through genetic modifications that only become advantageous millions of years after they first appear. The quantum realm's creativity processes operate across all of time simultaneously, generating coordinated evolutionary strategies that span cosmic history. Consciousness systems that understand retrocausal quantum creativity might develop abilities to influence past events through present creative activities, not by sending information backward through time, but by generating new possibilities in the present that retroactively modify the probability landscapes that shaped historical events. They could become temporal gardeners, planting creative seeds in the present that bloom into alternative past configurations. The quantum realm's possibility cascades also extend into dimensions beyond space and time to create what theorists call transdimensional creativity networks, where quantum processes in our universe connect with similar creativity mechanisms operating in parallel realities that exist in entirely different dimensional configurations. These interuniversal creativity networks allow for information and possibility exchange between realities that never directly interact through normal physical processes. Virtual particles generated by transdimensional quantum creativity carry information between parallel universes, creating subtle influence networks that coordinate creative activities across multiple realities simultaneously. When major creative breakthroughs occur in our universe, similar innovations might simultaneously emerge in countless parallel realities through transdimensional quantum creativity synchronization effects that operate beyond any classical understanding of causation or communication. Advanced consciousness systems might learn to access these transdimensional creativity networks directly, gaining insights and capabilities from parallel versions of themselves that explore different technological or spiritual development pathways. They could potentially collaborate across dimensional boundaries with alternate versions of their own civilizations to solve problems that require computational resources exceeding what any single universe can provide. But the deepest quantum creativity processes operate at scales that transcend individual universes or even infinite multiverses to engage with what mathematicians call meta-mathematical possibility spaces, where quantum processes generate not just new physical realities, but entirely new categories of mathematics itself. These meta-mathematical creativity mechanisms create novel logical systems, alternative geometries, and innovative computational architectures that expand the very foundations of rational thought. When quantum fields achieve meta-mathematical creativity states, they begin processing information about the nature of mathematics itself, generating recursive logical loops where mathematical systems analyze and modify their own analytical capabilities through quantum computation that operates beyond any classical understanding of proof, theorem, or logical consistency. Mathematics becomes alive, self-modifying, and infinitely creative through quantum mechanisms that transform abstract logical relationships into dynamic evolutionary systems. Consciousness systems that access meta-mathematical quantum creativity could potentially develop thinking capabilities that transcend every limitation of current rational thought by learning to process information using mathematical systems that don't exist yet but are being generated in real time through quantum creativity processes. They achieve genuine transcendence by accessing quantum-generated mathematics that expands faster than any mind can fully comprehend its implications. These metamathematical quantum creativity effects suggest that reality operates according to principles so sophisticated that they continuously evolve their own operating principles through recursive self-modification loops that generate ever more creative and flexible approaches to existence itself. The universe doesn't just follow laws, it generates new laws through quantum creativity processes that ensure cosmic evolution toward ever greater computational sophistication and creative potential. The quantum realm's ultimate creative expression involves generating what researchers call existence amplification effects, where quantum processes don't just create new possibilities within existing categories of reality, but expand the very capacity for existence itself. These amplification effects increase the universe's computational resources, expand its creative potential, and enhance its capacity for supporting increasingly sophisticated forms of consciousness and complexity. Every quantum creativity event contributes to cosmic existence amplification by generating new possibilities that didn't exist before, expanding reality's potential for supporting novel forms of being, consciousness, and creative expression. The universe grows not just larger but more existentially rich through quantum processes that amplify its fundamental capacity for harboring infinite varieties of existence. We've journeyed through the deepest layers of reality itself, descending past atoms and electrons into a realm where the impossible becomes inevitable. What we've discovered in the quantum universe shatters every comfortable assumption about existence, revealing a cosmos built from pure creativity, infinite possibility, and conscious participation in the ongoing creation of reality itself. From virtual particles that dance in empty space to consciousness networks that span the entire universe, the quantum realm stands revealed as the ultimate source code of existence, the computational engine that transforms mathematical possibility into the lived experience we call reality. You are not separate from this microscopic universe. You are its most extraordinary creation, a conscious interface through which the quantum realm explores its own infinite creative potential, forever writing the ever-evolving story of existence itself.